Today we want to take a look at a vector. A vector is a segment measurement with both direction and length, magnitude. So if I look at my vector v, we put it in pointed parentheses, so we know we're talking about a vector instead of a point. If I look at the vector a sub 1, a sub 2, or x comma y, or whatever you want to call it, the first number is always your left to right move. Then your second number is always your up or down move, just like a point, or just like your slope. I can write my vector in component form if I'm giving a starting point and an ending point. Notice that it's x sub 2 minus x sub 1 and y sub 2 minus y sub 1. Because our vector has direction, there is a difference between this vector, which starts here and ends here, versus this vector, which starts here and ends here. Even though they may have the same length, they are two different vectors. So it's very important that when we're writing our vector, if we're given 2 points, that we always take the difference of the x's and the difference of the y's, but x2 minus x1 and y2 minus y1. We can also write our vector in terms of I and j as a little sum. They go back and forth between writing it in its component form with the pointed parentheses or in terms of I and j, but it means the same thing. We can just write it either way. We also can find the magnitude or the length. Notice that if we're talking about getting from one point to the other, a left and right move and an up and down move, we're always creating a right triangle. So we can use the Pythagorean theorem, and the magnitude of my vector, we know we're looking for the magnitude because they put it in absolute value bars, is always equal to the square root of the x component squared plus the y component squared. So let's take a look at a vector u that starts at negative 5, 4 and ends at 4, 8. We want to find the vector u and find its magnitude. If I go ahead and I plot my points, let's start at negative 5, 4. There's our starting point, and we're going to go to the point 4, 8. There's our ending point. So there's my vector u. If I take a look at how I traveled, how I got from start to finish, I'm going to go forward 1, 2, 3, 4, 5, 6, 7, 8, 9, and up 1, 2, 3, 4. So that would be the vector 9, 4. I can also find it by taking the difference of my x's and the difference of my y's. So let's go ahead and do that. My vector u is going to be the difference of my x's, 4 minus a negative 5, and the difference of my y's, 8 minus 4. So you can see that algebraically we also get the same vector that travels forward 9 and up 4. If I want to find its length, notice that when we traveled forward 9 and up 4, we created a right triangle. So using the Pythagorean theorem, we can find the magnitude, the length of vector u, by taking the square root of my x component squared plus my y component squared. And you can leave it as a radical, or you can always simplify it down. So we can leave it as the square root of 97, or you can write it as a decimal as approximately 9.85, since we're looking at length. Same idea with question number 2. Question number 2 this time gives us the vector, gives us our starting point, and wants us to find the ending point. So let's go ahead and take a look at our starting point. We're going to start at 3, negative 4. So 3, negative 4, plot my starting point. And it says this vector u is going to travel back 10, up 7. So let's go back 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then up 7, 1, 2, 3, 4, 5, 6, 7. So if I look at my vector u, I can easily, if I graphed it, now find my terminal point. Well, my terminal point ends at negative 7, 3. But let's say that I didn't want to graph it. If I didn't want to graph it, then I know that the vector negative 10, 7 is made up of, I know my x sub 1, I don't know my x sub 2. So I could take x sub 2 minus 3. Same thing for my y's. I don't know my second y, my y sub 2, minus a negative 4, but I do know my first y is negative 4. So then if I set my x components together and my y components together, negative 10 is equal to x sub 2 minus 3. I get a negative 7, which checks out. And if I set my y's together, 7 is equal to y sub 2 plus 4. Subtract the 4, and I get the 3 for my second y. It also asks me to find its magnitude. We know that magnitude is length, so I want to take my vector here, negative 10, 7, and find its length. The length is always equal to the square root of my x component squared plus my y component squared. So if you want, you can leave it as the square root of 149, or if you want to write it as a decimal, it's about 12.2.